Hello Year 12 and welcome back to our second video here for our third topic on correlation and regression. We are specifically looking at correlation in this video here. I know I used this word a little bit in the last video where perhaps I maybe should have used association, but no, I think it's okay. So correlation has to do with how neatly, how reliably our bivariate data forms a straight line in this case anyway. Okay, it's the strength of the association. Yep, so I think we're quite within our rights to use the word correlation instead of association. Now it is, we can see here, this is what we would call a strong or even a very strong correlation. You know, we draw the line between strong and very strong is impossible to say. But anyway, here is a strong negative correlation because it's going down. Here I cannot really predict if I chose a point somewhere for this x value, would it have a small y value like this one or a large y value like this one? I don't know. I can't reliably predict where another data point belongs on that graph, so I cannot determine any correlation. Here, a moderate positive correlation. I can definitely see there is some correlation there. We have no real values down in this bottom right corner or the top left corner. Right, we know that our data belongs in here. However, right, there is plenty of variation within that. Okay, so that's the idea of strong, moderate. Perfect, remember, forms a straight line. Now for this idea of causation, right? Causation means that it causes, or one of these things causes the other one to occur. Righto. We could say something like a good causation relationship that, you know, the amount of money that I earn is probably fairly strongly correlated to the amount of money that I spend. Right? If we looked at lots of people and what they earn and what they spend, you'd probably see a fairly strong correlation there, and you could make a good case for causation there. You know, it's certainly easier to spend the money that you've got. Yep. Anyhow, might not be a perfect example, but it is tempting sometimes to see this causation relationship when it's not necessarily there. Here is some ridiculous data set that I found that examines the relationship between, or the association between the divorce rate in the US state of Maine and the per capita consumption of margarine. Now, you would not think that the consumption of margarine and the divorce rate in northeastern United States have anything to do with each other. But look at the graph. What do you know? There is a very strong correlation there. There would not seem to be any causation. Okay, it's a coincidence. You look at enough data sets, sooner or later you will find two that have a similar pattern. Right, you join them together and you go, wow, look at this, we have a correlation and there must be causation there. Not necessarily the case. Be critical with these things. If you are an economics student, I suspect that you have probably spoken about these things before. Anyhow, there is a silly comic strip there. You can pause and read that if you like, or it'll be in your notes. But we have this thing called a correlation coefficient. It's abbreviated to R, Pearson's correlation coefficient. There are, in fact, I think, a few different ways of calculating them. This is the one that we use in this course, correlated to R. It will always have a value somewhere between -1 and 1, -1 being a perfect negative correlation, 1 being a perfect positive correlation, and 0 being no discernible correlation. Okay, we have those things. Now, let's see if we can match these things up. We have an example. Now, this one here. This looks pretty close to a perfect positive correlation, so that should be R approximately equal to 1. So I'm going to say this one here, yep, I reckon that must be A. This one here, we have quite a strong negative correlation. It's not -1. Right, do we have any other negatives that are going to be... So I would say it's probably... This will be a -1. Right, in fact, we might find that one and put it on there. That's going to be I there. That one's going to be I, but this one will be close to that, so -0.9, I reckon that one's B. Okay, so we're done. Next up, C is quite a strong positive, not as strong as this, but stronger than this. Okay, yeah, we've already taken care of this one. This fella here will be the next highest, so that's going to be G there, and this one then, I imagine that will be that one there, is C. Okay, we're just sort of doing it by elimination. You can't look at it. You can't look at one of these things and know what the correlation is, right? Not quantitatively, right? You don't know what the number is, but you can compare it to some others and say, well, it's higher than that or lower than that. Now, what other positive correlations do we have? This is quite a weak positive correlation, right? So that must be something like R 0.3. That sounds pretty good. There's my F done, and E would look to be 0. So there's that one done. Now we have two fairly weak negative correlations. This is going to be the weakest. So that's this one here, right? Closer to 0. That's my H. And D, negative 0.5. There we go. How'd you find that? Good one? Wonderful. Moving along again, you might in fact wanted to write them on here like negative 1 or something. Maybe you want to write them on your notes there. I don't know, whatever suits you. Anyway, moving along. We can calculate the correlation coefficient on our calculator. You can do it manually. I don't know how to do that, or if I do, well, if I ever did, I've certainly forgotten now. But with the magic of technology, here we go. Here is calculator, and we can, using some menu items here, we can calculate the correlation coefficient. Now, you might want to pause, rewind. Certainly follow this along. You'll need to practice a few times. It's moderately complicated. I'm not going to repeat it. You can just rewind. So, first of all, change the mode to stats to... Ooh, geez, I don't like that. Let's do a reset first. Second function 9, 3 equals AC. Ignore that first bit. Reset your calculator. Second function 9, 3 equals AC to make sure everything's gone. Now my mode. Oops. And 2 for stats. Okay, there we go. And I want menu item 2 here, so we've got an X and a Y up the top. If you have an X and an F up the top, you are in the wrong area. Reset, try again. You need an X and a Y up the top. Now we put our data in. 190, I find it easiest to do all of the, say, X's first and then all of the Y's. The X is going to be the top row, independent variable, so we've got 190, 192 equals, puts it in there. I can see what's there. I'll show you what happens if I make a mistake. Oops, that's not the right one. I can just arrow up and type over the top 199. Okay, 188, 197, 187, 194, 198, 193, and 199. Okay, that's my 10th score. That's good. I've got that list there. Now if I arrow down and across, it puts me over here. Now it is important that they match up, but we should be fine to get there. So 192, 194, 202, 189, 200, 188, 196, 202, 197, and 200. Okay, they all look pretty good. I can arrow through them if I like. Have a quick look. They all look, without checking super carefully, they look pretty good. From here I press AC. I have not deleted those. They are saved in the memory. The 0 there is a reminder that we're in stat mode. Okay, from there we need to access our stats. We're looking for the correlation coefficient. That's all. The second function, 1 here, 5 reg, whatever reg stands for, I can't remember, and 3 for our correlation coefficient equals doesn't equal 0, 0.98. That's pretty strong. R equals 0.98 to 2 decimal places. There we go. That is the correlation coefficient and how to calculate it. It is really important that you remember that process on your calculator, okay, because you do need to do that potentially in an exam. But that's why you've got a video. Pause, rewind, watch it again, calculate those. If you've got any questions, let me know. Otherwise, I will see you in class.